The objective of this case study is to evaluate the effect of introducing carbon capture, amine absorption into SAGD CPF using InsituSIM. This example assumes fixed steam capacity. Post-combustion occurs when CO2 is captured using amine as a physical solvent. Steam is used for providing the reboiler duty of the amine regeneration column. Let's head to the GHG Control tab to add a carbon capture block. Now let's take a closer look at the carbon capture block. There are two inlet ports, with those being steam and gas. The inlet steam is used for providing the solvent regenerator reboiler duty. The default values for reboiler temperature and energy use, CapEx, OpEx, and power requirement of the block are based on MEA-based carbon capture system. The carbon capture block has three outlets, with those being the treated flue gas, water, and CO2. The treated flue gas is sent to a stack block. The CO2 is sent to CO2 compression and then to CO2 sequestration. Water is recycled back upstream of WLS. The steam capacity of the OTSG is fixed to 655,000 kilograms per hour, as in the base case. Bitumen production should be deleted from the well pad, otherwise the problem would be infeasible as it would be overspecified. Now let's add a splitter on the HP steam from OTSG and send a portion of it to the carbon capture block. Let's set the HP steam splitter option to use flow rates. Therefore, no split ratio needs to be defined. Now let's solve the case and fill in the following table found on screen. Click on the splitter property view to determine the split ratio for steam to well pad and steam to carbon capture. Let's head to the reports. Here, we can view the bitumen production found in the Process Summary tab. Now let's take a look at the Energy Efficiency tab. Let's expand the details for power consumption. Here we can find the carbon capture power consumption and CO2 compression power consumption. Click on the GHG Emissions tab to determine the direct, indirect, and total GHG emissions. Let's take a look at the Economic Analyzer. Now let's click on the Output tab. Let's have a look at the financial performance. Once we enter the General tab, we can determine the NPV. Now let's take a look at the results found in the table on screen. 17% of the total steam from OTSG is used by the carbon capture reboiler, thus reducing bitumen production. 90% of CO2 is removed from the flue gas as specified in the carbon capture block. Increased power use for carbon capture and CO2 compression results in increased indirect GHG emissions. Total GHG emissions decreased by 65%. The NPV of the SAGD flowsheet is decreased by 700 million Canadian dollars due to the lower bitumen production, CapEx, and OpEx associated with the carbon capture and compression.